before we do that, I want you to do this division problem. Repeating decimals. Let's say I've got the fraction 1/7. I want you to change it to a decimal by taking 7 and dividing it into 1. On your mark, get set, go. The winner will get a chicken dinner. Actually, probably not. Although it is Cheap Chicken Monday, isn't it? Cheap chicken is pretty good. Does anybody get tired of Elijah always like wanting to be first?
No.
Grace, what about you? You got an answer to that question?
Not yet.
Oh yeah, probably not. Goss, your job. Lights and doors. Ask Jules, she'll help you. She'll remind you. The answer to that is repeating decimals. The answer is, oh, Elijah took his hand down. Let's see, wait, were you not done, Elijah?
Well, I thought it was, maybe that's what it was.
Oh, isn't that ironic?
Yeah.
7 goes into 10 once. 7 goes into 30 4 times. 7 goes into 20 2 times. 7 goes into 60 what? 8 times. 7 goes into 40 what? 5 times. What?
Oh, I got it.
Wait. Did I do something wrong?
No.
Riley, you got what?
0.142857.
No.
What? 5 7.
Repeater. 142,857.
This all repeats, right?
Yeah.
That's what you should have got there. Which boils down to the one point I want you to make. This and this are the same. 1/7 is that. It's just that you can't work with this if you're doing mathematical operations. You want to change it to this. This is what you need to understand. Every repeating decimal has a fractional equivalent. Where do you spell that? Okay, if it is a repeater, you can change it into a fraction. If it is not a repeater and it goes on forever, you cannot. That's why that is irrational. And this is rational. Every repeater is rational. If it doesn't repeat and doesn't end, as pi doesn't, then it is not able to be turned into a fraction and it is not rational. If it repeats, you can make it a fraction. If it doesn't repeat and goes on forever, you can't make it a fraction. And that's why square root of 2, you put it in your calculator, you get all these decimals. Never does the pattern repeat and never does it end. It's irrational. Today, we figure out how if I gave you this, would you ever get the fraction 1/7? That is what we're going to do today. So here is a repeater decimal. Let's say you've got this, 0.27 as a repeater. What fraction is that? Please don't tell me it's 27 over 100 because it is not. Okay, it is not 27 over 100. It's close to 27 over 100, but it is not. In math, you have to be exact. Riley's got an answer. He thinks it is. Oh, I thought you did. Jason says
1 night. 2 nights.
2 ninths is 0.222222. Remember, the ninths are in. The best thing for you to say is I don't know, because unless you figured it out, Elijah,
3/11.
I don't think so, is it? Well, maybe it is. Wait, it is 3/11. Were you looking in the book? How'd you know?
Yes.
Just guess?
Yeah.
Well, unfortunately, just guessing, well, I should give you a really hard one. See if you figure it out. Wait a second. Nah, I'm not gonna do that, because I'll waste the time. Here is the steps to change a repeater to a fraction. If you follow these steps, I think you'll find it not that difficult. Step number 1. Make the decimal equal to, I just put the letter F there. It's any variable. So just know that you do this. You write F equals 0.27 repeater. Not a hard step, is it? You can just humor me with you that there's no thinking there, you just do that. Okay? Step number 2. Make a new equation by multiplying both sides of number 1 equation by a 1 with as many zeros as digits. This is hard. This is long, but it's easy. That repeat. I'll let you write that, and then it is nowhere near as hard as it sounds. And put on top. Put above equation number 1. Once you're done writing that, just listen, it's really easy. A picture paints 1,000 words. So then why can't I paint you? I'm waiting for the awkward silence of non-writing. Some of you are really slow writers. Okay, so here's what you do. You look at the number of digits that repeat. This has 2 digits that repeat, the 2 and the 7 repeat. Okay, so you put 2 zeros at the end of 1. 1 with 2 zeros is 100, right? You multiply both this and this by 100 because of that. This becomes 100F. This, if you multiply this by 100, what happens? You move the decimal 2 places over, right? And if you move the decimal 2 places over, what does that actually become? But 27.27 repeater. It just slides the repeater over 2. You end up with 4 digits instead of the 2. Okay? You got that? It's going to be that same little pattern. You just multiply it by, move the decimal 2 places, and it ends up looking like that. Step number 3, here's the beauty of the bicameral system. Number 3 is you subtract the 2 equations. And this is some classes have ooh and ah for days after this. No, we haven't done the ooh and the ah yet. This is 1F, by the way. If I subtract those things, 100 F's minus 1F is 99 F's. And look what happens over here. I subtract a repeater 27 from a repeater 27. Guess what? They go away. There is no repeater because this is the same thing from the same thing. You get nothing over here. 0 from 27 gives you 27. Look, so now the repeater's gone, and we can deal with this simply by doing what? Step number 4 is solve the equation. Which means you divide by 99, get F by itself, divide by 99, and if you reduce that, ladies and gentlemen, you get, divide both by 3, 9, 11s. I'm sorry, 3 11s. What did I do wrong? Wait, where did I go wrong? Tell me.
Divide.
What? Oh, I divide by 11. No. I divide by 9. Sorry, it's been a long weekend. You get 3 11s. If I ever get really bad, put me home. You say that out loud, I like it. Be with the other people that don't remember anything. It's not like it'll be bad for me. I'll teach them old people math. I'll agree. Now, another example. Another example, how about this one? So here, try this one, 0.16. If I'm changing, 6 is the repeater. Okay? You have to be careful because you gotta do a little decimal work sometimes. Following the steps. Step number 1, put it equal to F. F equals 0.16 repeater. Step number 2, you're going to multiply both sides by a 1 with as many digits, with as many zeros as digits that repeat. How many digits repeat here? It's not how many digits are after the decimal, it's how many repeat. Lainey? Just 1. So I'm going to multiply both sides by 10. F times 10 is 10F. This one, if you multiply by 1, okay, you get 1.6 repeater, correct? 1.66 repeater. Okay. Step number 3, subtract them. This gives you 9F. This one, the repeaters go away, but you're still left with a decimal, 1.5. Are you with me? And then to solve it, you end up with 1.5 over 9. Now, there's an issue here in that now I've got a decimal in a fraction. What can I do to resolve that? Because I don't want to deal with a fraction. I could divide them both by 3, but I'm still going to get a decimal in there. I got to get rid of that decimal. Somehow, Elijah, I'm going to multiply both top and bottom by 10 because I don't like decimals and fractions. So you end up with 15 over 90. Then you can reduce it to 1/6. Did I get that right? Not in the old folks' home just yet.
No, it's not, it's 1/6.
Thank you. You can join me.
I got you.
Okay. Got that? A couple more examples and I think you'll be home free. How about this one? Born free. Free and point 0. I don't know if I want to do that one. That's not. They give you too many easy ones. Well, let's just do point 12. 0.12 repeater. 1, 2 repeat. 0.12 repeat. So again, step 1, F equals 0. Repeater 12. Step 2, ask yourself how many digits repeat, which is 2, so you can multiply both sides by 100. 100F equals, move it 2 places, you get 12.12 repeater. Subtract them, repeaters go away, you're left with 12 here, and 99F over there. Divide by 99, divide by 99. 9 to 3 goes into a what? 4 over 33. 4 33rds. I want a hard one. Oh. Sure, let me give you one to try. How about this one? This one's going to be a tough one. 0.027 repeater 7. What fraction would that be? Did somebody put? I'll give you a second to try that on your own. What did we do with this, by the way? You only got your leaves colored? How did that work? Why was that so slow? Are we not focusing, Jason? Are you done with it? 3 over 110? How did you get that?
Because here, got 3 11s.
I don't know, maybe that's right. I can't tell based on just looking at that, but that would be the thing, but maybe it is. Are you sure? Maybe you should try it the other way and see if you get the same thing. Did you get 3 over 110? Elijah says No. Again, I'm going to get, I think, a decimal and a fraction, so you're gonna have to get rid of that decimal at some point. But if you follow it step by step, I believe the children are our future. Just try to follow the steps. Uno, dos, tres. Uno, dos, tres. Marco, you got an answer? Nancy, you have an answer?
I got 1/306.
1 over who? 1 over 360. Isabella, did you get an answer? G? Come on, people, this is not rocket science, yes? Did you get something?
Yeah, but
Just tell me.
153.
153rd. Drew, did you get something? No. Aubrey? 1 over 3 is 0.3. There's no way that can be. I can tell you 1/3 is a decimal, 0.3 repeater. Riley, just say your answer for crying out loud.
I don't get it.
Did you follow the steps? At what point did you not
Get
get?
it, but.
What'd you do?
Where are you? I don't know what I did.
Keith?
1 over 36.
1 over 36. All right, follow, work with me here. Step 1. So how many of you got this far? F equals 0.02 repeater 7.
Yeah, I got that.
How many people got that far? Who doesn't have that? Can I ask why you wouldn't do that? Because I didn't think that was really that difficult of a step.
Oh, yeah, I got there.
Step number 2. How many digits repeat? Just 1. So you're going to multiply everything by 10. So by 10, this makes this 10F. How many people didn't get 10F? Because that's the easy part there. What part of that doesn't make sense? It's 10. You are then just going to move the decimal over here, making this 0.27 repeater. So you're going to do point, the points have to line up, 0.2, sorry, 0.27, and you have to keep going till you get the repeaters above each other. So you should get 0.27 repeater, 0.277 repeater. Okay, because it's just, you could keep going as many as you needed, but you want to stop right above that. So when you subtract them, how many people got that? Okay, when you subtract them, this gives you 9F. The repeaters go away and give you nothing. Now you are left with 5.25. Divide it out. Here is where life gets a little difficult. We don't like decimals there. To get rid of the decimal there, you just move the decimal 2 places or multiply by 100. Multiply by 100 ends up being 25 over 900. And then you have to do the reducing thing. Divide 5 into them, you get 5 over what? 180. And 5 goes into 180 36 times. Tell me how many people got this far and got stuck? You did get 0.25 over 9, it's half the battle. How many people missed up on this part right here? You think you could do it on the next one? We'll try another one. It's all about I want to find a little part. Here, this one, 0.138 repeater. 0.138 repeater. Again, follow the steps. It's not terribly difficult. I mean, it's not something that you're incapable of. Uno, dos, tres. 0.138 repeater. 138 repeater. It's just a small 3-step problem. You like Craig Hall enough to say it twice?
I was.
People's next one's
Yeah.
It was fun.
We should start with
And
then
the Super Bowl got stuck.
yeah, the Super Bowl. We gotta start with
No,
those.
that was. I thought
And
only
add
Super
like-
Bowls.
Yeah.
Like three of
And
them.
then add like bowling
Only
balls,
Super
the one
Bowls.
What?
That's
Craig
Then
Hall?
you get one stuck.
The one.
You should
Yeah.
do
Fine,
distance.
I'm good at dodge.
Throw
Dodge
distance.
is
No.
okay.
What they did
Because according to my mother,
only the big ones.
No, you could.
I thought
your
you
aim
could.
right. You could hit that.
Just don't roll the people.
my mom wasn't there.
Yeah, but.
You could like roll up and just right out.
Yeah.
Alright, you got an answer?
Well, to make the players in the game.
Huh? I don't even know where the problem came from. I'm not even sure. I don't even actually have the answer in my book. I'm gonna have to do that one.
It's just so interesting.
Nancy, are they doubting your answer? What do you have?
5/36.
What?
5/36.
5/36. Well, now, wait, shh, Brianna, I don't know if it's right or not, but I do know we figured out what 1/36 was. If 1/36 was this, then 5/36 would be 5 times that, and maybe it is. What is 0.27 times 5? Does that give you 135? What was it? 132?
138.
Step number 1.
I didn't.
0.138 repeater.
Yes.
Number 2. 1-digit repeat, so you're gonna multiply by 10. So that's 10f. This decimal's just gonna move 1 here, so the decimal goes here, the 1 goes in front. The 3, 8, 8 repeater. You gotta keep going till you get the repeater above the repeater. So you're subtracting 9f equals, repeaters go away, 5 is here, 2 is here. I might be with Brianna on this one here.
Yes. I counted.
Divide by 9, divide by 9, multiply top and bottom by 100 to get rid of the decimal. 125/900. 25 goes into that top number, what, 5 times, into the bottom number.
36.
Yeah.
Jeez, we were counting. We were doubting it.